Good afternoon, I'm Jeff Watkins. I'm a technical architect at BJSS working on the upcoming e-referral service project, which, as you may know, is replacing the existing choose and book implementation. Now, I gather some of you come here for spine information. Unfortunately, due to the current stage spine's in, we can't talk about that at the moment. So, sorry to disappoint you, feel free to leave if you don't want to listen. Okay. So in lieu of that, today, I'd like to take you on a tour of how our development toolchain has evolved since I've joined the company in 1999. What you're going to see is a cut-down version of what I'd like to tell you. Is in the process of producing all this, produced over 40 slides, and that was not going to work in a 20-minute time slot. So please do feel free to contact me. My email address will be at the end of the presentation if you want to have the whole presentation. Okay, so without further ado, I'd like to quickly cover what we're going to talk about today. Okay, so let's briefly cover what we used to do in 1999 and the challenges we faced, and basically most of it is down to our development methods and how we've moved on, matured. Why there's no one simple solution to the problems we've faced, what people are going to get from an integrated tool chain, and some of the lessons we learned along the way. So to begin all this, we need to go back in time when I started at BJSS 14 years ago. So, as we probably all know, back then almost all projects were waterfall, and I think nowadays that does take a huge amount of the brunt of the blame for the lack of delivery during those years. Don't know how many of you are involved in large-scale development back then, but the model started to grow about the 10 developer mark, and a lot of this was to do with development practices rather than actual project management methodologies. And one of the things back then, due to the lack of automation and manual intervention at all stages, projects were very difficult to measure. It was very difficult at any given stage to see how high the quality was of any particular part. It was difficult to quantify how close to done a project was. And of course, virtualization was a glint in somebody's eye at this stage. So everything was on a physical instance. Everything was in a server room. It was backed up manually repaired, packed up and when decommissioned. And this got to be such a problem for us as a smaller developer, development house. At one point, we actually almost melted our building's power supply. The guy from Yorkshire Electricity came along and poked and said, "You're actually going to melt that." So we had to spend a month without air conditioning and lights just to keep our server farms running. Okay. And deployment time was always something to fear. So that meant that deployments were done infrequently. It was always tools down, all hands to the pumps, and it led to uncertainty and downtime in live environments, so people just avoided doing it. This is mainly because everything was done manually. Surprised to learn now, so I go work with a lot of different organisations, mainly financial. I'm fairly new to the healthcare sector. Although a lot of them have learned about Agile, and banks especially are very heavily invested in Agile, but it's at the management level, and they have not moved their development practices on. So they learn all the dogma, and they don't seem to have moved on from a development point of view. So the development's as uncertain as ever, and they don't understand why Agile doesn't work for them. So if you're running a development project and it's still not delivering, you have to ask yourself a number of difficult questions. Things like, does your code build? And that might sound like a simple question, but unless you've got some kind of continuous integration or some kind of automated way of doing this, the answer is unless you actually fire up a compile and look yourself, you don't know. And does your code work? Well, if your testing is all, especially your regression testing is all manual, the answer is, I don't know. Until I do it manually, I don't know. Does your code meet quality standards? Without a large amount of manual intervention and testing, again, it's an answer you can't give immediately. So moving on to the present day, what we'd actually do nowadays. So I want to show you a generic toolchain that we'd use on one of our projects here in 2013. So I'm not going to take you through all these boxes because it can seem quite intimidating at first. But effectively, this covers the entire development life cycle, all the way through birth, where the requirements being put into an Agile planning and tracking repository. Now, this is a generic example. I'm going to fill it in the next slide, 2 slides on, with some actual examples of real software. All the way through to the developer being assigned the task, working the IDE, integrating to the version control system, code reviewing, again, done tracked and automated, through into a continuous integration environment, automated testing tools, known good builds are pushed into an artifact repository, which is then picked up by an automated deployment tool, which then pushes onto your target environment, which could be a test environment, it could be UAT, it could be live, it could be a technical testing environment. Okay, so for this, you could go for a closed source, paid for solution, something like maybe TFS provides a lot of these facilities out of the box. But it is somewhat limiting when it comes to platform, and it's also very expensive. I priced up some very basic setups like this, and it was tens of thousands of, maybe even hundreds of thousands of pounds for a 50 man project. So in order to deliver the maximum benefit without the costs and the vendor lock-in, BJSS nowadays put together a predominantly open source solution. So in general, we've found many organisations are actually moving away from monolithic licensing models and vendor lock-in. Especially, I don't know if you've read the government ICT strategy, but that is heavily encouraging people not to choose paid-for closed source solutions. So now we actually, in order of preference, choose free open source software, something like Jenkins, free disclosed source. So although the Oracle JVM, you can get the source code for it, and you can run it for free, and you can distribute it at will, it's what they call disclosed source, because you can't directly contribute. That's the difference in open source and disclosed source, is that you can take it and you can look at it and you can build it yourself, but you can't contribute. Then of course there's a paid disclosed source, something like the Atlassian stack, things like Jira. Then there's a paid semi-closed source. I don't know if anybody here has come across Enterprise DB. It's a layer that sits on top of Postgres. This is used a lot by people migrating away from Oracle. That's at its core a free open source piece of software with a set of closed source paid for extensions on top. And then you've got paid closed source, something like TFS. So here we are. This is now an example. An example development tool chain. So starting on the left here with these are actually paid for products, Jira and Greenhopper. Moving through into Eclipse, through Gitflow, which is a version control productivity tool, into Git, which is free and open source, into Jenkins, which is a continuous integration server, into Nexus, which is the artifact repository, which is deployed by Puppet onto CentOS Linux VM. The actual environments are commissioned using Vagrant and technical testing done using JMeter. So the total cost for a chain like this for a 25-man project is less than £3,000 for the actual software licenses. Now, what we do with this typically nowadays is we will virtualize the entire stack. Now, although that isn't free, it's relatively inexpensive, and the cost of taking up extra environments here, especially if it's for short periods of time, is actually very small indeed, because you can bring up and tear down environments on, say, something like Rackspace very quickly, and if you actually delete them afterwards, the cost can be a matter of dollars, a handful of dollars, rather than thousands of pounds commissioning a full-size technical testing environment. So, if you actually genuinely require something completely free, you have here a version of the previous slide, but with completely free open source software. So, I've replaced Jira and Confluence with Redmine, which, although it's very well featured, is not quite as fully featured as Jira, and HipChat with Kanban, and I think I've replaced Fisheye and Crucible with another Git tool called Gerrit. So that is a totally free open source stack. So So implementing such a tool chain drastically reduces the manual effort involved in day-to-day development. So although this covers most of the product development lifecycle, I'm just going to focus for a sort of minute on the development part. So back in 1999, or whenever we started writing unit tests, this would be the number of steps you'd have to take to actually write some code. And then you have here on the right, obviously most of the steps excised, and you can see all but 3.5 of the steps there are being excised, and the steps that are left are the ones that are the creative ones, the ones that actually require you to think. The rest of these, running the unit tests or deploying to a that's repetitive tasks. You don't need to think to do these things, yet people will still do them manually. And when you do something manually, there's a room for error to be introduced. So we excise all of the steps where there's a repetitive task that can be done automatically. So what are people going to get from this tool chain? So obviously, project managers are going to get timely visibility of the project progress, quality and stability. And one of the things I want to guarantee from this is delivery on time. Quality assurance are going to get objective metrics concerning the quality of the deliverables, and also they're able to assess which stories have been genuinely delivered. And testers obviously only ever want to receive working deployments, and by doing them automatically, you guaranteed a much higher hit rate of working deployments. And also you can do it on a more regular basis. If you're doing deployments manually, you find it's a very labour-intensive thing, and you tend to do it as infrequently as possible just because of the amount of time it takes. So with continuous delivery, you could deliver at every branch push if you wanted to. So business analysis is going to get a robust traceability between the stories and their implementation. The solutions architects are going to be able to see via the review tools the architectural vision and principles are being adhered to, and provide feedback on specific parts of the code base without having to build the entire application themselves. And the cell and team leads can understand where an individual task is in the development process. So IT, by virtualizing the stack, IT admin are going to get obviously fewer machines in the building, which means less work maintaining hardware, less network administration, less headaches in general. Developers, well, all developers usually want to do is actually write code. They don't want to be messing around with deployments for the most part. They like checking in, working well-engineered code, and only consuming working code from other team members. And of course, everybody can get their weekends and evenings back. They'll have to get to have hobbies, see natural light, have holidays, etc. All the stuff we didn't do in 1999. So implementing this kind of thing over a number of years, we've learned a few valuable lessons. So obviously keeping pace with the change in the IT industry is very, very hard. On some projects we did hang on to some technologies a bit longer than we needed to. I think Ant and Cruise Control lived on for a few years than they should have done, long after many people have moved on to Jenkins and Hudson. And when you're changing this stack over, it's important to just make stepwise changes. Introduce one piece at a time, otherwise you do risk basically bringing down the whole project. It's very tempting on a project that's been running for a number of years to keep the status quo, but almost any project can benefit from having some of these parts of this tool chain implemented. And as we found with the Jira stuff, sometimes it's better to pay a small amount and gain a lot. The Jira stack starts from $10 for 10 users, which is excellent value for money. And now the actual licensing model is a bit steep after that. It's $1,200 for 25 users per piece of the stack. But we've found that paying that small amount extra, we've gained a lot over and above the open source alternatives that, although they exist, are not anywhere near as well featured. And one size does not fit all when it comes to tool chains. When designing ERS, we attempted to make the PHP tool chain fall in line with the Java tool chain, and attempted to Mavenize the PHP build, and we found that we were fighting every step of the way. And it's just because we wanted to reduce the number of moving parts. And when we stopped fighting with and worked in a recommended way, with a recommended toolchain for that particular technology, everything just started working for us. And one thing, BJSS have a number of offices over the world and on various client sites, and this is something we do particularly poorly, and we could do with improving on, is actually learning from other teams. Because there have been a number of times when we've maybe created a Puppet deployment and somebody on another team said, oh yeah, we've done that. We could have saved you days worth of effort. And so inter-team communication is something we're working on improving, and it's definitely key to keeping the lessons learned in the company. And one of the really controversial topics whenever you try and put a technical delivery in place is the business will actually want some functionality being delivered at the same time. And attempting to do that as you're actually putting the backbone of your toolchain in place, it can be disastrous. You have to have a TA who's willing to say, look, we need to get all this in place first before we start delivering functionality. Get the foundations dry before we start delivering screens. And this is one we always fight with people over. And time again, whenever we attempt to do it, it always ends up with more rework than we'd have done if we'd have just done it properly in the first place. And leading on to that, don't delay any of it. It's always far harder to do it in retrospect. Many times more to do in retrospect. You build up technical debt on a project with frightening rapidity. If you've got no quality control in place, and you're doing it all manually, the rapidity at which you build up technical debt will frighten you, and it can break a project. And when it comes to metrics, things like code coverage have become a really hot topic when it comes to reporting back to management as a measure of quality. But you have to be really clear about what you want from them, what they really mean. Because things like code coverage, is an example, is a really poor example of overall project quality, and is easily faked. And one thing we found implementing ERSs and other recent virtual projects is although the cloud providers like to publish pretty much everything straight out of the box, it's not. And if you want to have a secure private network, etc., there's actually quite a lot of setup time involved in that. And if you don't have a lot of in-house knowledge, that can actually result in really being more cost-effective to hire in some DevOps consultancy. So we found that BJSS we're a provider of software services. We don't actually have a product. And with that in mind, a lot of our projects are diverse in their nature. So sometimes we'll have clients who want to work on their particular stack, or we'll have to work within other constraints. So we can't force one particular solution on all projects. Now, for a product-based company, if you just sell a product or a suite of products on one technology stack, actually having a canned, virtualized way of doing it for all projects might work for you. But if you're working with different technologies, then there will be an element of reinventing the wheel. But we've found that several parts of it are actually project and platform agnostic, and we've adopted them across pretty much all of our projects. Things like Jira, Git, Jenkins, and SonarQube and Puppet. We've found that they work equally well on most projects. So in retrospect, there are a number of interesting key points we took away from this all. Yeah, it won't solve a broken cross-team enterprise delivery. As much as having everything automated in your build and quality process will actually ensure that individual bits of code are of high quality, we find that it won't help an enterprise talk to each other. And also, you need strong technical leadership on this, because it's very, very easy just to say, to drop the bar and keep lowering the bar every time you find, or just allowing exceptions every time you find problems with the quality of the code, and ignoring tests and allowing things to continue to fail, allowing builds to keep being read for weeks on time. And I mean, that's a genuine example. We went into a client who'd had a broken build for a month, and they just didn't seem to be particularly interested in fixing it. And that way, again, you start building up technical debt with frightening rapidity, and it's very difficult to turn it around. And if you've got a huge legacy code base, this will help you tell you how much technical debt you've got, but it's not going to fix it for you. It can tell you how much work you've got to do, and it's quite nice and quantifiable, because when you've got a list of 10,000 violations and you know it's taking you roughly a quarter of a day to fix an individual violation, it's a reasonably good metric of how much work you've got to do to fix it, but it can't do it for you. So it's limited in that respect. So what we end up with out of all this is clean, sustainable code with continuous integration. We should never have a broken build. So when it comes to quality, you can set your own bar, and when you set, so you expect people to always improve the quality, never ever let it drop, and when it's reached the predetermined level, it's maintained. And again, as I said before, as deficiencies are a known quantities, you know how many violations you have, how many things are failing. You can give a reasonably good estimate of how long it's going to take to fix it. And visible code actually adds to project confidence. If you can go to your clients and say, here's a Crucible instance, you can come along and review our code. Doesn't mean you have to be able to build it all and run it all up in an environment. You can just come along and review it. It gives confidence that you're actually delivering something of quality. So when it comes to virtualization, one of the biggest things we've taken away from it is the prepackaged VM for developers has saved us so much time. We were working with one client who were using virtual machines, but it wasn't a prepackaged one, and it was taking between a week and 3 weeks for a developer to actually get up and running. We can get a developer up and running within a couple of hours now. We can have somebody completely new to the project with a completely blank machine up and ready to develop some code within a day or so. Automated commissioning of build and test environments in the cloud is another real boon. Working with banks in the past and having to wait weeks or months for a build and test environment to be commissioned or cleared down and cleaned, it was painful. And this we can now have a new instance spun up and ready again within an hour. And you can have as many as you want. If you want to have another environment, you spin another one up. Once you're done with it, you delete it, and it's only cost you a matter of dollars. And obviously, it's inexpensive when it comes to licensing implications. You don't have to worry about busting your license. When you're using an open source stack, you don't have to worry about breaking your license. You don't have to worry about how many copies of MSDN you've got on machines. With continuous delivery, we take the absolute sting out of actually deploying the code. So we can do it per build if you want, upon demand, whenever you feel like it, instead of being a thing to fear. And one of the key parts of it is this point here. We use the same deployment method for development, test, pre-prod, live, all the same. So you know that mechanism is reliable. So it now is no longer a thing to fear. You shouldn't fear software. The software should fear you. And that is the end of the talk today. Any questions?